This video will walk you through all the answers to this review for our Unit 2 test. It's our first test for Unit 2. It covers everything in our book up until this point, which involves finding lengths of segments, finding areas, and anything to do with square roots or cube roots. So I'm going to go through and solve each one. You don't have to watch this whole video. This is just for if you have a question on a certain problem, you can fast forward to that part and just watch that part. You can watch the whole thing. It's up to you. All right, so I'm going to start with number 1 here. It says draw line segments to connect points B, A, T, and S in that order. So let's start with that. I'm going to draw these line segments on here to connect B. Oh, whoops, didn't want that to happen. Let's try that again. Draw a line segment to connect B to A, to T, to S. And we want to form a polygon, so I'm going to go ahead and connect it back to B here. So, all right, that was easy. 1. So now for 1A, we want to answer what shape is that figure. Quadrilateral will be a little too broad. It is a quadrilateral because it has 4 sides, but we can get even a little more specific, and we can say this is a parallelogram. That's a 4-sided figure in which the opposite sides are parallel, and that's what it is. We can't say a rhombus because the sides are not the same length. Now it says, without using a ruler, find the lengths of the line segments BA, AT, TS, and SB. So basically every side of this figure. So the top and the bottom sides are really easy because we can just count those. Remember, we count the spaces between the dots. So from B to A, it is 1, 2, 3, 4, 5, 6 units. And I believe the bottom one is the same. 1, 2, 3, 4, 5, 6. So that is from S to T or TS. So those are each 6 units. Now we want to count these diagonal ones. So this is somewhere where we can use Pythagorean theorem. So for example, to find the segment from A to T, I can pretend that that is the hypotenuse of this right triangle. The lengths of my right triangle are 1, 2, 3 for the first leg and 1, 2, 3 for the second leg. That means I know that if I drew a square here, its area would be 9. Same for this one because 3 times 3 is 9. And I know that the squares on the legs of my triangle have to add up to be the area of the hypotenuse. So 9 plus 9 is 18. So I know the area of this square is 18, which means that the side length is just the square root of 18. So you can write that as the square root of 18. Another way you can write this, and I'm going to look at this other segment because it's the same, right? This is a 3 by 3. If you look at this segment from B to S or from S to B, it is joined by those dots in the middle. Remember, we learned that anywhere that connects one dot straight diagonally to the next dot, that's the square root of 2. So that's just the square root of 2 3 times. So you could also write this as 3 square root of 2. So this one's the same, the square root of 18 or 3 square root of 2. I would take either of those answers there. All right, so on part C, it asks us how the opposite sides or how the lengths of the sides compare. So what we can say a few things here. For example, we know that the opposite sides are congruent. That means they're the same length, which was true in this figure. The opposite sides were the same length. Now we also know that if you figure out the square root of 18, it's going to be between, let's see, 4 and 5. So that's smaller than 6, which are the other sides. So we know that segments AT and SB, which are the same, are shorter than, whoops, my pen just stopped working. Found a little piece that fell off here. Are shorter than the segments that are 6 units long, which are segments BA and TS. So you can say if things are the same length, and you can say if some are shorter than others. And I think on the test I require you. All right, for part D, it wants to know what the area of the figure is. I don't know what that little mark right there is. So if we go back up here, I'm going to erase this work that I've already done because I want to find just the area of that parallelogram, so I kind of want a nice clean workspace here. So to find the area of a parallelogram, well, there's a few different things I could do. I think what I'm going to do is break up this figure. So I'm going to break it up like this. A square in the middle and triangles on the outside. So this square in the middle is 1, 2, 3, 4, 5, 6, 7, 8, 9 units. That was easy. So for the area, I'm going to add 9 here. And then I've got these triangles on the side. They are a base of 3 and a height of 3. 3, 3. So all I have to do is 3 times 3, which is 9, and cut it in half. So that's 4.5. So this triangle is 4.5, and this triangle is the same because it's a 3 by 3. 4.5. So I'm going to add the 9 in the middle plus the 4.5 on each side. Well, 4.5 and 4.5 together makes 9, so I'm really just adding 9 plus 9. So I get 18. So when I go down here to my area, I know that it is 18 square units. All right. For number 2, I'm going to arrange these numbers on a number line, and we want to make sure that we rewrite them. We don't just draw arrows to where they go. So one thing that might be easy to do at first is to figure out what the decimals of all of these are. You will have a calculator on the test, so you can use that here. So for 22/7, what I can do is just 22 divided by 7 in my calculator to figure that out, and it's 3.14. Not pi, but it's kind of close to it. The square root of 9, I know that one is 3. The square root of 0.36, if you type that in your calculator, you get 0.6. Maybe you knew that one in your head. The square root of 2, you might remember that one. We talked about it a lot. That is about 1.4. 1.2, well, that's just 1.2. You don't really have to make that a decimal. You just leave it the same. And then the cube root of 64, remember that means what times itself 3 times equals 64, and that's 4, because 4 times 4 times 4 is 64. So now we can put these on this number line. So when you put them on the number line, I want you to write them in the way they were given. So for example, 22/7 is 3.14, so we go to 3.1, and there's a little teeny bit farther. And we want to write 22/7 there. The square root of 9 is equal to 3, so I'm just going to go right to that 3 and write the square root of 9. The square root of 0.36 is 0.6, so that's between 0 and 1. It's 1, 2, 3, 4, 5, 6 little lines over. So this is the square root of 0.36. The square root of 2 is 1.4, so I'm going to go to 1 and then 1, 2, 3, 4 tenths. So this is the square root of 2. 1.2, I just go to 1 and 2 tenths, so right there, it's 1.2. And my last one is the cube root of 64, which is just 4. So I just go right here and I write the cube root, it's like a square root symbol with a little 3 on it, of 64. All right, we are halfway there, although I will say these ones on the back take longer. All right, so back here we're finding the perimeter and area of each of these figures. Honestly, I think area is a little easier on these. So I'm going to do area first and then erase my work and find the perimeter. So to find the area of this first one, I think the best method is going to be the box around it method, because it has some weird parts that I don't really feel like breaking up. So this whole box's area is, let's see, 1, 2, 3 times 1, 2, 3, 4, which is 12. So I just did 3 times 4 to get that 12, base times height. Now we need to find the area of all these parts on the outside that are not within my figure. They're not within that weirdish triangle sort of thing. So I'm going to break up just this part right here, because right here I've got just 2 units. A rectangle, it's 2. Next to that, I've got a triangle that's a 2 by 1. So I do 2 times 1, which is 2. Cut in half, that's 1. I've got this triangle on the upper right. It's a 2 by 2. 2 times 2 for base and height, which is 4. Cut that in half, it's 2. And then I've got this last triangle. It's a 3 by 2. 3 times 2 is 6. Cut in half is 3. So that's how I got all those numbers. I'm going to add those up. So 3, 4, 5, 6, 7, 8. Those add up to 8. So I'm going to subtract 8 from that box, and I'm left with 4. So I know that the area of that is 4 square units. For the other one, it's kind of easy to break this one up on number 4. So let's see, I've got right here, the area is 2, 1, 1, 2, and then this triangle here is a 2 by 2. 2 times 2 is 4, cut in half is 2. So I just add up 2, 4, 6, 7, 8. So my area is 8 units squared. On my answer key, it says 7 on my online, so make sure you realize that I got that very top part wrong on that one. All right, so now I'm going to go through and find the perimeter of these. I'm going to do that in red, and I'm going to erase the area work here. So if you were looking for area, you might want to skip back a little bit. So to find the perimeter, remember perimeter is all the side lengths added up. On this first one, I only have one easy side that's really easy to count. It's this side right here, which is 2, and I said I was going to do it in red. So for my perimeter, that part is 2. Plus, okay, now these parts are kind of weird. So I'm going to have to use Pythagorean theorem a bunch of times to find these. So now I'm going to do this side right here. All right, so if I use Pythagorean theorem for that side, I'm going to draw a right triangle. I'm going to do 2 squared plus 2 squared. So I'm finding this square and this square. That's 4 and 4. Well, 4 plus 4 is 8. And I take the square root of that. So this side right here is the square root of 8. So I've got 2 plus the square root of 8. Now I'm going to do it in green so you can kind of see the difference here. I'm going to do this side right here. I'll use Pythagorean theorem again. So I've got one leg is 2, one leg is 3. 2 squared, so this square right here is 4. 3 squared is 9. And 9 plus 4 is 13, so this side is the square root of 13. So I'm going to add on the square root of 13, and then last I've got this little segment right here. And if I do my Pythagorean theorem, I've got a 2 and a 1. So 2 squared, this square is 4. 1 squared is 1. 4 plus 1 is 5. So this side is the square root of 5. So the perimeter of this, I'm just going to let you guys write it like that. 2 plus the square root of 8 plus the square root of 13 plus the square root of 5. If you wanted to make it a decimal, I think you get around 10.7. So you basically just find each side and then write a plus sign between them all. All right, so let's find the perimeter of this next one. This one's a little easier because I've got a bunch of segments that are easy to find the length of. So right here, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 10 nice segments. Plus, I've got this thing right here. We can use Pythagorean theorem. It's a 2 by 1. So I do 2 squared, which is 4, plus 1 squared, which is 1. 4 plus 1 is 5. So this thing is the square root of 5, which makes this one's the same. So it's also the square root of 5. So I can write 10 plus the square root of 5 plus the square root of 5. Or you could write 10 plus 2 times the square root of 5. Either one's fine. I'll just write 10 plus 2 square root 5. If you wanted to write that as a decimal, you can. It's up to you. That would be 14.5 units. Those were the longest problems on this thing. All right, so let's go down to these next types of problems. These are like one of the homework assignments we had was number 7 and 8. So in this dot grid, we're going to draw and label a line segment with the length of the square root of 13. So I'm going to do some work off to the side here. I just want this segment, wherever it connects these two dots, I want it to be the square root of 13. So I know that this square on it is going to have an area of 13. So what I need to do is find two numbers that these legs areas could be that add up to 13. Remember, I only want to use perfect squares. So if I go through my perfect squares, I'll list them here. Let's see. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. And so on. Well, I can find two that add up to 13, 9 and 4. So I can make this square 9 and this square 4. which would make this side length down here 3, because 3 times 3 is 9, and this one 2, because 2 times 2 gives us 4. So really all I need is 2 dots that are connected by going over 3 and up 2. So I can start here, go over 1, 2, 3, up 2. And then I just want to label that, like it said to in the problem, square root of 13. If you made any 2 dots on there that are separated by 3 in one direction and 2 in the other direction, you got it right. It might look different than mine, but you got it right. Now we're going to do the same thing for the square root of 10. So I want this segment to be the square root of 10. So I need these 2 squares here to add up to 10. Well, 2 perfect squares that add up to 10 are 1 and 9, which would make these side lengths 1 and 3, because 1 times 1 is 1, and 3 times 3 is 9. So we just need to draw a dot somewhere, go 3 over and 1 up, and that makes the square root of 10. So if you drew a line that goes 3 in one direction and 1 in another direction, you got it. All right, we've got 2 more here. So on part C, it says which is greater. And on the thing, it says square root of 3 plus square root of 3 or the square root of 9. Explain how you know. Well, you have a calculator, so let's just figure out what these are. So the square root of 9, we know that's exactly 3. So then let's figure out what the square root of 3 plus the square root of 3 is. If you figure out the square root of 3, I think it's about 1.7. So we're doing 1.7 plus 1.7, which is definitely more than 3, because 1.5 plus 1.5 gives us 3. This actually gives us 3.4. So what we can say is that the square root of 3 plus the square root of 3 is greater, because it's about 3.4. And the square root of 9 is only 3. So that one's really easy if you have a calculator. One more, it's like the one before. We're gonna, they gave us S, it's right here. We need to find T so that the length of that segment is the square root of 5. So just like we were doing before, we want to find what these 2 squares on the legs can be that will add up to 5. Well, 2 perfect squares that add up to 5, I can see them right here, 1 and 4. This square can be 1, this square can be 4. That makes this side right here 1, because 1 times 1 is 1, and this side 2, because 2 times 2 is 4. So from this point right here, which is kind of like right here, we just need to go over 2, up 1. So over 2, up 1, and that's where T would be. You could go 1 in one direction and 2 in the other direction, and any way, and you would have that one right. So that's your review. Email me if you have questions, but hopefully that helped you.